Hello students, today we are going to see some more important question. Come on, let us go for it. Which of the following undergoes nucleophilic substitution reaction exclusively by SN1 mechanism? They asked SN1 mechanism, which of the following this can take part very effectively. So in that, 2 points you have to note down. One, it is nucleophilic substitution. The other one, it is SN1 mechanism. You know very well which can take part in SN1 and SN2 reactivity series also you have gone through. Now, benzyl chloride, as we write in that formula way, I think that will be more effective, easy way we can identify. CH2Cl, it's a benzyl chloride, ethyl chloride, CH3, CH2, Cl and chlorobenzene. This is chlorobenzene, Cl, and this of course isopropyl chloride. Yes, in that SN1 mechanism, bulkier group will take part. In that among bulkier group, this might be. Now, why can't these and all, which is not take part? Why? Because this is a least bulkier group. It cannot take part. It might be the last one. And chlorobenzene actually less reactive, lone pair of electrons of halogen atom, it is delocalized by benzene ring, and this of course less reactive. Only two groups are there, and this is one group, this is two group. Highest thing it might be. So here carbocation, it is more stable. Why it is more stable? Because by resonance. Okay, so due to that resonance only, this will be exclusively by SN1 mechanism. Hope you're clear with that. Okay, we'll go for some other question. The next question is actually very interesting question. The correct order of increasing the reactivity of carbon and halogen that bond towards nucleophile of following. So that means increasing order. You know very well the reactivity series of SN1 and SN2. You be thorough, right? Now, among these compounds, you can identify very easily which will be more reactive, which will be less reactive among the reactivity series. So in that way, which will be more reactive? Let us go for the compounds. Chlorobenzene, ortho para dinitrochlorobenzene, and tertiary point it is there, CH3 thrice connected with carbon. Okay, now that fourth one, the secondary. So this is tertiary and this is secondary. CH3 twice, this is CH3 thrice. Okay, among these, which will be more reactive? Where your vote will go first? The first you will go for here only. Why? Tertiary carbon it is there. So it will be more reactive. So 100% carbon halogen here nucleophile increasing order 100%, this point your mind will go. Okay, the second one, tertiary, secondary, primary and methyl, right? So secondary, this is that second one. And third one, you know, nitro group actually best leaving group, electron withdrawing group, they will say no. So naturally third point you will go, the last one you will go. Okay, now third it's greater than second, it's greater than third it is greater than fourth, it is greater than second, it's greater than first. Let us go and find where it is. Third it's greater than fourth, it's greater than second, it's greater than first. Okay, shall we go for this voting? Is it correct? Why? Because why can't these three will not be possible for it? Why the second one it is possible? The third it is most reactive because it is a tertiary carbon, and secondary carbon, and best leaving group it is electron withdrawing group, leaving group. So that is the third point, and then last one. So third, fourth, second, and first. That is the way I just mentioned, 1, 2, 3, 4, and these and all, it is not like that. That is what these three are wrong and this is correct. Hope you're clear. Why do we select this? What is the reason we selected, and why can't we select this? Hope you're clear. Okay, let us go for some more interesting question. Let us go for one more interesting question. Metaxylene reacts with bromine in the presence of ferric bromide. what are the compounds formed? Let us go for that first and foremost. What it is? Metaxylene. See, now this is the formula for metaxylene benzene ring connected with 2 CH3. See, meta point 1 CH3 and the main point. Okay, now this one reacts with bromine in the presence of ferric bromide. Okay, this is actually electrophilic substitution reaction, aromatic electrophilic substitution reaction. So you are getting ortho directing group, para directing group. Which one will be forming? Now actually this point it is identical. Both this one cannot change that. Okay, let us go for the products. Now here, see here, you can put it ring also, or here CH3 and CH3. This will be common. Okay, now I just put it both the point so that it will be easy for you to understand. CH3, here CH3. Right, now bromine will go and attach. You know where it will go and attach? Ortho position and para position. Bromine only it will change, but this is a constant. This point it is constant, it will be same. It is an identical point, identical twins like. Only thing which will go and change that position, bromine only. So bromine ortho, bromine and ortho point and para point. So in this way you can identify the products. Okay, now this is the question and answer. Now in that this point, where do we identify among these four? Now that A group, no ortho position, this will not be the correct, this may be correct but this is not correct, so this is wrong. And in this position, first one correct and second one no, this is also wrong. C, ortho and para, yes, this is correct. And let us go for the last one, this one and this one, no, this is also wrong. Okay, now which is the correct option? Now why these are all wrong option? Hope you're clear with it. So according to the electrophilic substitution reaction in aromatic hydrocarbon, so this is ortho and para directing group. According to that, this will be constant. You remember, whichever compound comes, this will be constant. Only bromine position it will be changing. Where it will go and change? Ortho and meta directing group. So this is ortho position and para position. Hope you're clear with that. According to that, which is correct on option? C is the correct option. If you find that correct answer, very good. Take the next interesting question. It is the reaction of C6H5CH double bond CH CH3 with HBr. HBr along with alkene. The famous rule, I hope you remember. That is Markovnik's rule only. Let us identify the product. C6H5CH double bond CH CH3. Yes, combined with HBr, it gives what is there? Okay, as we are writing this one, H plus Br minus, where it will go and attach this Br, of course, where it will be lesser hydrogen, but both are same. Why? You know, carbocation will be more stabilized due to that resonance. C6H5 is there, no, so naturally this Br will go and connect with this point only, not here. So this point, this hydrogen will go and attach. Why this Br is connected over here? Both are same hydrogen, because it is carbocation, it is more stabilized due to resonance, so the bond breaks. So you are getting the answer C6H5 CHBr, here CH2. Of course, one hydrogen it is attached over here, CH3. So this is the product. Okay. So why this bromine is coming join over here? Due to that resonance, the C6H5 is there now. Due to that resonance, this bromine and it carbocation, it is more stabilized due to resonance. That point you have to mention. And this is the product. Now let us find out where is the product here as the same. Now is this correct? No, this is anti-Markovnik's rule, means it might have been coming. Okay, this is wrong. And this one, bromine bond, it's not breaking only. and I don't think so. This is not the correct one. And the next one, yes, C6H5 CHBr CH2CH3. Yes, group C, it's correct. Option C, it's correct. Next one, C6H5CH2CH. No, this bromine will not go here. Why? Because here resonance. That's what I mentioned. Carbocation, it is stabilized by resonance. So here it might be correct. This is the correct answer. This is wrong. I hope you're clear with that. Why these are all wrong and this is correct. So if you identify, no, you will get some other better answers also. See, now as I mentioned, it is anti-Markovitch-Cox rule. This might be the correct because it's a straight chain. And Markovitch-Cox rule, it is a branched chain. And one more point here, suppose if it is C6H5 is not there, you can think it over. But here both the hydrogen are same numbers. So which one you will confuse it. So for that to avoid here, because this carbocation, it is more stabilized due to that resonance. Hope you're clear with that. Okay, let us go for some other interesting question. Next, one more interesting question. Dihalogen derivative X of a compound, that is a hydrocarbon, three carbon atoms reacts with alcoholic KOH. Three carbon atoms attached with two halogen, and it reacts with alcoholic KOH and produces hydrocarbon which forms red PPT with ammoniacal cuprous chloride. What is that X compound? And again, this X compound gives an aldehyde on reacts with aqueous KOH. So what is the compound? Now three carbon, that means CH3, CH2, CHCl2. Here I wanted to mention geminal and vicinal. Geminal means one carbon attached with two halogen. Vicinal means two carbon attached with two Cl. Okay, so this is what it is, geminal, and this is a vicinal. Okay, now come to this point here. Here that this is three carbon attached with dihalogen combined with alcoholic KOH. So what is a product? See, actually here it is two halogen atoms. So only one halogen haloalkane reacts with alcoholic KOH, means you will get double bond. That means elimination reaction, beta elimination, Steiser's rule. You know, no, so that point. So but here two halogens are there, so two halogens removal of that, so definitely you will get alkyne formation, not alkene. Only one halogen means alkene, that hydrogen, one hydrogen will be removed, you will get double bond. But here two halogen means you will get triple bond. So CH3 C triple bond CH. So this halogen and this hydrogen both will be going out. So this is what it is. It reacts with the cuprous chloride. What is it, cuprous chloride? Ammoniacal cuprous chloride. Cu2 Cl2 in that ammonia, NH4OH, ammoniacal cuprous chloride. So what is the product? The same product, but it has a red PPT. Okay, CH3 C triple bond CH. So actually this is a red PPT. You are getting alkyne propyne. Yes, you got that for the first answer. Yes. Now the second answer, what they are mentioning, it's gives an aldehyde on reaction with aqueous KOH. So this is alcoholic KOH. Now let us go for that aqueous KOH. So here in this point, aqueous KOH, aqueous KOH. So aqueous KOH, it is a substitution reaction. Now what is the formation you are getting? It is two halogen atoms are available. So what it is? Aldehyde formation you will get it. So CH3 CH2 CH, here one OH and here one OH. So the water removal, what is it, water removal here actually? So here the water removal, H2O, no, the removal of water. So CH3 CH2 CH, here one O. Okay, now you can write it this way also, CH3 CH2 C double bond O, here H. You can write like this also. So that means this is the compound you are getting. So that means CH3, CH2, CHCl2. So that means CHCl2, here one chlorine, here one chlorine, right? So that means 1 dichloropropane. Okay, now let us go and find out which is the correct option. 1 and 3 dichloropropane? No, it is not possible. Here 1 and 2 dichloropropane? Naturally, this is also not possible. 2 and 2. No, because if you put this way, you will not get the correct formation what they have given in the question. Now, this is also wrong, and final answer 1 dichloropropane. So this is only the correct option. Why? Because here for that aqueous KOH you are getting aldehyde formation, and alcoholic KOH you got that alkyne formation according to Steiser rule beta elimination. Hope you're clear. This is the correct option. Okay, as you look at the question, you feel somewhat, but you think it in a depth way, you will get the answer. You have learned all these points. Hope you understand. Thanks for watching. The next question, it is still more better. Yes, which one of the following compound will give racemic mixture on nucleophilic substitution reaction by OH minus ion? They have given three compounds. In that, which is a correct compound? Let us go and identify. Actually, they have given option A, B. A, it is only one. B, it is 1, 2, 3. And C, it is 2 and 3, and D, it is 1 and 3. Let us go and find out. So, first and foremost, here, racemic mixture means what it is? Here, racemic mixture means at least it should contain one chiral carbon. What is it, chiral carbon? A carbon connected with four different groups or atoms. That is called chiral carbon. That is actually asymmetric chiral carbon. Okay. Now, in that 1, 2, 3, which is among such kind of that racemic mixture. So, racemic mixture comes under what it is SN1 mechanism. SN1 mechanism, that is SN1 mechanism only, it gives dextro and levo. That is what we have mentioned. It is a racemic mixture. So carbon connected with four different groups or atoms. Okay. Now in that is called chiral carbon, and that is asymmetric carbon. And one more thing, secondary halide which has to be attached with that carbon, that should be optically active. So these are the points or approval for this point. So which are the points are there here, in which compound it is available? So that means here first point, here what it is, carbon. This carbon, it is connected with C2H5. Here CH3. Here Br. Yes, we can identify. And here CH3, both are same. Here CH3, C2H5. Here CH2. No, this won't be correct because it is a chiral carbon we required. This also won't be correct. I hope this will be the correct answer. So the option A will be the correct. Why? First and foremost, what do you mean by racemic mixture? Racemic mixture means it has to contain only at least one, what it is, chiral carbon. What is it, chiral carbon? The carbon which is connected with four different groups atoms which should be there. Okay, four different groups or atoms should be there. And next, one more point, what it is, secondary halide should attach with that carbon. Secondary halide, so this is the secondary halide which is attached with that carbon. Okay, now that should be optically active. So these are the points can be approval for that. So in that, which is the correct option? 1. It's a correct option. I hope your vote also will go for that option 1. Hope you understand. We'll go for some more sums. Yeah, one more interesting question, like match the following. In that, you will come to know all the type of reaction. When you look at that equation only, you will come to know what kind of reaction mechanism and all. Okay, now chlorobenzene reacts with ferric chloride. You are getting ortho and para directing group. So this is what kind of reaction? first and foremost, this is what it is, aromatic reaction. So that means here ortho and para directing 100% it is elimination. So here this one will be coming. So electrophilic aromatic substitution reaction, it is substituting. Okay, now the next one here, this is alkene reacts with HBr. What it is, Markovnik's rule. So here bond breaks, you are adding, so that means it is electrophilic addition reaction. Hope you're clear with it. Okay, now here benzene connected with CH3 CHI, OH minus ion, OH minus ion only, it is nucleophile, remember that. Okay, now you are getting what it is, CH3 CHOH. So what is the answer you will get it? This is aromatic, right? So in the two among here, nucleophilic substitution, nucleophilic aromatic substitution. So this answer is the exact. And the last one here, nitro group attached with benzene along with Cl connected with OH. This also OH, it is a nucleophile only. And here OH here. Substitution reaction. Yes, in one mechanism, 100%. This will be nucleophilic substitution. Of course, this also, but here nucleophilic substitution, yes, in one mechanism they have given. Hope you're clear with it, this point, and all these things and all, whether it is correct or not, you just to check it and mention in my comment box. Okay, hope you got so many ideas with that. And I would like to give you alcohols, phenols, ether, and carboxylic acid. Next topic I'm going to take. In that, so many questions we will see. Actually, organic chemistry, it is interrelated. So from here also you will get alcoholic question, and from alcohol chapter also haloalkane questions will be coming. It is like interrelated. Okay, let us go for that another session. Hope you're clear with it. Thanks for watching.